again, everyone. Last time we introduced the inequality symbols less than, greater than, less than or equal to, and greater than or equal to. Today we'll be seeing how we can use these symbols, along with variables, to express a continuous range of numbers. Let's consider some variable x to represent our possible numbers. If we have the inequality x is greater than or equal to 0, this means that our variable x could be any number that is greater than or equal to 0. To visualize this, let's go back to our number line. Recall when we had a single value for the solution to our variable, we placed a point or filled circle at that value. But now we will have a continuous range of values. The way we represent this range is by shading the appropriate region on our number line. We always want to start with the number that's in our inequality, in this case the 0. Because of the greater than or equal to sign, our variable x can be that 0. So we will put a filled-in circle at that value 0. Then we also want all numbers that are greater than 0, or in other words, bigger than 0. Remember that bigger numbers are towards the right on our number line, so we will be shading towards that bigger direction. And we'll leave an arrow to indicate that this shaded region will continue forever towards the right. And here we have a visual representation of all the numbers that are greater than or equal to 0. Now let's say we wanted all numbers less than 0. Again, we'll look at the number here in our inequality, which is 0. However, this time, we don't have the equal to line under our symbol, which means x cannot be 0. In those cases, instead of a filled-in circle, we leave an open circle at that value. Then from there, we'll be shading in the appropriate direction. If we want numbers less than 0, we want the numbers that are smaller than 0, which on our number line are to the left. So for our numbers less than 0, we'll shade out everything to the left of that open circle, leaving an arrow to indicate we're going to keep on going forever. And for one more example, consider x less than 3. This time the number we should start at is 3. We don't have an equal to line under our inequality, which means we can't be equal to the value of 3, so we'll leave an open circle. And again, we want x to be less than 3, or rather any number smaller than 3, so we'll be shading to the left again. One quick way you can see which way to shade your number line is if we have x greater than some number. You can think of the inequality symbol here as an arrow pointed in the direction you should shade. Then for the less than, we can similarly think of this as an arrow to shade to the left. However, this only applies when the variable is on the left side of our inequality. There are also times when we have more than one inequality to express our range of numbers. We could potentially have x sandwiched between two numbers, like this first example, or we could have two separate inequalities joined by an or, like this second example. Let's take a look at this first example where x is sandwiched between two numbers. Reading this inequality with words would be -2 is less than x is less than or equal to 1. Or you can also think of this as x is between -2 and 1, then paying attention to what numbers x could be equal to. It's not equal to 2, but can be equal to 1. Keeping in mind these two numbers, we'll go to our number line. X won't be equal to -2, so we'll put an open circle there at -2. but it can be equal to 1, so we will put a filled circle at 1. Then we want all the numbers between these 2 points. So we'll shade between these circles we've put on our number line. This is the range of numbers that x is allowed to be from our inequality. Another way we could think about this is to separate this string of inequalities into separate inequalities. In this case, we would have -2 less than x and x less than 1. If we separate them like this, the "and" is important, as it reinforces that both of these inequalities must be satisfied. On the other hand, if we now have 2 inequalities separated by an "or," as long as one of them is satisfied, that is enough. What this means for shading our number line is that we simply shade each inequality like we normally would, just on the same number line. For this example, let's start with the x less than or equal to -2 and shade that on our number line. We would look at that -2 and see that we could be equal to that, so we would put a filled in circle at -2. Then if we want to be less than that, or simply looking at our inequality as a direction to shade in, we would shade to the left. But now we also need to consider the shaded region for x greater than 1. There's no equal to line under this inequality, so we'll go to the value of 1 and put an open circle since we can't be equal to that. Then we want the numbers greater than 1, or looking at the inequality as a direction to shade in, shade towards the right. Because these inequalities were separated by "or," we have shaded the appropriate regions on the same number line. So these shaded regions would be the solutions to this pair of inequalities. As we have shown, inequalities are a way to represent a range of numbers. These numbers could be solutions to some problem, or the domain and range of some function, among other examples. We also have another way to represent ranges of numbers called interval notation, which we will discuss next time. Until then,